This is the supplemental lecture video for week 4 in JIT 71. All right, the topics covered include what? It includes first, solving formulas, slope, and equation of lines. So some of the techniques we cover today will be similar to those from last week. All right, example, you'll see. Example number 1, solve for x. All right, now it's time to decipher the language of math again. What do you mean when you say solve for x? All right, so that means we have to isolate x on one side of the equation. So there are always the left-hand side and right-hand side of the equation, right? So when you solve for x, that means you're doing so. And then if you have two equations and two unknowns, then that will be a different story, because that means you probably have to figure out the value of x. But for this one, no. You just have to leave the x on one side when we have the other unknown variable terms on the right hand on the other side. So this is the equation given, and then let's see. Well, there are many ways to approach the final answer, and then I'll show you my way. So what I would do is to add 7x on both sides. Why? Again, because I want to cancel the 7x and negative 7x on the left. And in the meantime, I can subtract 7y and 2z together. And why? Because these two terms will cancel and these two terms will cancel too. All right. Then the result is going to be negative 12y. So the left-hand side will now have negative 12y plus 4 minus 2z. And then for the right-hand side, you only have negative 4x plus 7x, which gives you positive 3x. All right, so we're reducing the right-hand side, and then we are almost there. So I'll let you pause the video and think about what to do next, right? Make you think, and that's how I make you improve. So let's do it. And assume that you have paused the video. I trust you, and then let's move on. Right, so the answer is that we'll divide the equation by 3. Make sure you do it on the entire left and right hand side. We do that to divide out 3 on the right hand side, and that's how we isolate x. Okay, right, so x equals to the entire fraction on the other side, and then we swap both sides to get that answer. Right. So the question doesn't ask you to simplify the fraction, and you can't do that anyway. So this will be the answer. All right, example 2. Well, we solve the equation for r. Sometimes the wording will be different, and this is when we pay attention to the language. R in terms of s and t. What does it mean? So that means, all right, so remember, the phrase in terms of is extremely important in math, right? Don't overlook it. If you are asked to write a symbol in terms of other symbols, that means your expression should include s and t on the other side when you isolate the r. I'll show you. This is the equation given. We have fractions, so it makes the question a little bit scarier, but let me guarantee you, it's doable. And it's actually not that bad. All right, so we have 2 r's as denominators this time, and then we don't want denominators like that. So what would you do first? Pause the video and think about it. All right. Now let's go over the question. We multiply the equation by r. We do that to divide out r on the right-hand side. And then let me show you how that works. You expand the left-hand side term, then you ends up having r times s over r minus r equals to t. So now this is when you see that r's are divided out on the first term, right? If you expand the left-hand side, you get s minus r, which equals t, right? All right, so now you can add r's on both sides and take off t, but I'll show you one trick. If you have you have minus sign before the r's like that, and one trick to do is to flip all the signs on each terms. So you have negative s plus r equals to negative t. That's a good trick for you to do math if you have separated terms, like term number 1, term number 2, and term number 3. Mathematically, it is correct. That's why it works. Okay, next, we can simply add s on both sides of the equations. And then this is the result. Negative s plus s equals to 0, so that's why they cancel, and eventually you have r equals to s and a negative t plus s, and then we write the equation, and you have r equals to s minus t. Well, either answer works, so I think I can just box both of them and put them or on it. So this is it. This is the equation with r in terms of s and t. Right, now we're getting better with the language of math. All right. So that's how you solve this type of problem. But before I move on, let me show you something else. So if you're still confused by what we're doing, and if you're still scared by the symbols, then let me show you another way to understand it. All right, so first of all, when you see symbols that are normally variables which can be replaced by any value. So let's say r equals to 3, and then s equals to 4, and then t equals to 1. You have to make up the right, you can't just make up any number. You have to make sure you have the right set of number to satisfy the equation, okay? Right, so I'm doing this. I am doing this to help you understand why the method works. So plug in numbers, and then we'll have 4 over 3 minus 1 equals to 1 over 3. Does it make sense? All right, so we know that this equation is right. And then let me show you the technique I just showed before. So if I multiply both sides by 3, then what do I get? Think about it. I got 4 minus 3 equals to 1, right? So the equation is still satisfied. So you can multiply the equation by any number or divide the equation by any number. The reason for doing this is to modify the equation for getting an answer, but you didn't essentially change that equation. That's why the method works. All right, so that's the extra tip. And if you are not sure, so sometimes if the math phobia gets you and if you don't know why the method works, you can try to play with the numbers in this way, and then you'll see the info better. All right, then let's move on to another type of question. Example number 3. Find the slope and y-intercept of the line. All right, so at this point, you have to know the slope stands for the steepness level of a given linear function. And then that is the linear function with the increasing trend to show you that the data increase numerically. Right. There are applications of, about this type of graph, but we shouldn't focus on that portion because JIT is meant for you to understand the concept better. So I'll let you hear about the applications in 146, Math 146 instead. All right. So our goal is to find these two info when there is no other numbers given this in the statement. So first of all, this is the x-axis and this is the y-axis. And then we can actually tell the y-intercept right away, which is that one. The data point has a coordinate 0, -1. So when x equals to 0, then we can tell that the y-intercept as b equals to -1. So we call this a y-intercept because, right, y-intercept is essentially a data point that passes through the y-axis. Think about it. This is the vertical y-axis, right? The one I just highlighted. And then this is a data point from the red line that passes through the y-axis. It intersects with the y-axis. So when x equals 0, then this will be the answer. All right. So we figure out the first part. Next, let's figure out the slope. The slope is defined with the variable m. And then in case you can recall, the slope stands for the steepness level of a linear function. It can be positive for increasing trend or negative with a decreasing trend. And then if you have viewed the lecture videos, then you should know that slope equals to rise over run, and we can review what that stands for. So to figure out the rise over run, I will first of all pick 2 data points. I'll pick these 2 because they're either intersecting the axis or the grid lines. So for example, we have the horizontal shift from here to there to show you the shifting of the data point. And this is the vertical shift. So the horizontal change of the data x value is called the run. And the vertical change of the data value is called a rise. And then this is the first data point. So we'll call this x1, y1. And then this is the second data point, and you can tell the value by looking at the info here. We have 4, 2 on that final point in the given interval right there. So that will be x2, y2. Yes. And rise is found as the difference of the y values, and the run will be the difference of the 2 x values, and they had to be in the order. All right. So y2 minus y1 equals to what? 2 minus -1. Rise will be 4 minus 0. And it makes sense because the y value is changed by positive 3 and the x value is changed by positive 4. So the answer will be 3 over 4. So the steepness level of that linear function is 3 over 4. That's how you find a slope when a graph is given in this way. You have to pick 2 points, and it can be any 2 points that makes you feel comfortable, and then you can plug in the data points accordingly. Next, example 4. Oh, determine the slope of the line passing through the points -4, 4, and 3, -7. I have an idea. I can borrow the picture from last time. I can show you some other information once I solve the problem. So this is now the example with the data points given. Right, so we're talking about the line through the first point with -4, 4, and then we have the second point. They're given in order, so we can assign them in order for sure. All right, and then the slope will be y2 minus y1 over x2 minus x1. And then you plug in -7 minus 4. And the x2 will be 3, and the x1 will be -4. So when you plug in numbers, watch this negative sign. And then what do we get? We have -11, and then 3 minus -4 equals to what? Equals to +7, right? So that is the negative slope we found in the problem. And then let me have you visualize it on the picture. Right, so this is where we have -4, 4. Okay. And then this is where we have 3, -7. It's right there. Right. So if I connect these 2 lines, then yes, this is the second linear function with the negative slope. Because we have the run in this way, but we have the rise downward instead. So if the rise is not actually rising but dropping like that, then that means you have a decreasing trend, and that's why the slope is negative. Problem solved. All right, example number 5. Find an equation of the line that has a slope of 7 and a y-intercept of 0, -6. Okay, so let's take a look. We have the standard form of the equation of the line given. Sometimes you have that given in a certain problem, which is nice. All right, so let's see. We can list the information. M equals to 7, and then B will be -6, which is exactly the value right there. And then all you need to do in this question is to plug in M and B in the given linear equation. So your answer will be y equals 7x plus -6. And then write the equation, then you'll have y equals to 7x minus 6. Right, so that's exactly what you do. And then you make a professor, how about the x and y? Do we plug in values on them? Well, the answer is no, because x and y's are variables. They're unknown in this question. We don't know what they are. And then we plug in the known information, then that is the equation of line we are trying to achieve. Okay. All right. Next, example number 6. Give the slope and the y-intercept of the line, and we have the linear equation given. All right, now we're doing the opposite. We're using that equation to find the slope and y-intercept. And then you have to follow one rule. A linear equation always starts with with a single y. So whenever you see an equation given like that, you have to solve for y. You have to isolate y on one side of the equation. Because we want to match the format of the standard linear equation. So starting this way, and then if you recall the trick I show you, then you'll immediately tell that we are adding 9x on both sides. Why? Because we are canceling these two terms to get 3y equals to 9 plus 9x. All right, so we have the y term alone. Then we can divide the y term by 3 to divide out the 3, and then now you have y equals to 9 plus 9x over 3. And guess what? The right-hand side can be simplified as well. You can divide all the factors by 3. So the 3 over 3 gives you 1. And let me ask you this. 9 over 3 gives you what? That gives you 3 as well, right? So you have 3 right here and 3 right there. That means you can rewrite the equation as y equals to 3 plus 3x. We are getting there. And then to make it even better, we'll put the x terms. We'll put the x term first and then the number later. Then that equation matches the standard format where y equals to mx plus b. This is when you tell what the m and b's are. M equals to 3 and then b equals to 3. Slope and y-intercept. All right, so to do well in math, I'm encouraging you to practice more indeed. And then I will encourage you to train yourself until you're able to immediately tell what to do on an example. So, for example, if you read a statement like that, then you have to tell what you're doing within 5 seconds, and then you start the problem solving. Right. So that's how you do better and better in maths. Some people run out of time during a test because they don't know how to start. It's likely that they don't practice often. They don't practice this problem solving and thinking often. So make sure you're not making a mistake. Okay. All right. Make sure you start doing the homework and eventually the quiz for week 4, and then I will see you next time.